Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 2 video on the chapter Congruence, where I will discuss about the congruency of triangles related to, we will discuss not yet all the conditions, four conditions required for congruency of triangles, but we will try to understand the naming convention of a triangle. That is, how do we name when we name a triangle? Then what are the names of its sides, the angles, and then we will understand matching or correspondence between two triangles, and then finally we will try to understand the 6 matching parts for congruency of two triangles. So this video is part of the playlist CBSE Mathematics for class 7 following the textbook of author R.S. Aggarwal. If you have not watched the part 1 video on congruence, where I discussed about I'm sorry, I forgot the topic. It is highly I highly suggest that you watch the part 1 video on this chapter congruence, so that you will maintain the continuity of your study and understanding of this chapter. If you are new to my channel or not yet subscribed, I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have the rough notes prepared on today's topic, where I will discuss about a few aspects before going into the conditions of congruence of two triangles. These are the foundation concepts that you need to understand before we discuss about all the 4 cases rules, that is the SSS, SAS, ASA and the RHS rules. Before going into that, it is very important that you understand these concepts. Okay. So on the right hand side, I will do any kind of discussions, and on the left hand side, I hope you can see my notes. Okay. First thing, recalling naming convention of sides and angles of a triangle. So you have a triangle. As you can see, you have a triangle, and you have some vertices. So in this triangle, we have this triangle XYZ. Now, it is not that the only name you can, or the only way you can name this triangle is XYZ. No, you can name it other ways, like YZX or ZXY. So you can name it a triangle in different ways based on the letters of its vertices. In this triangle, the vertices are XYZ. So with these 3 letters XYZ in different orders, you can name the triangle. But the moment you name a triangle, it will have it will automatically define the name of the sides, of the triangle, and of course which angle is opposite to which side. So if you, in this example, in this figure, if I name this triangle XYZ, I could also name it some other way, like YZX or even XZX. If I name this triangle as XYZ, then what are the sides? What are the sides? The sides are XY. So how do we know the sides? We take 2 letters at a time from the letters of the triangle that we named. We named it XYZ. So the first 2 letters is XY. So the first side will be XY, and of course we put a bar to specify that it is a segment. Okay, one thing I would like to say, that regarding these properties of triangles, in which was the previous chapter, I said that in a triangle, let's say I have a triangle ABC. I'm roughly drawing a triangle ABC, and possibly I've always mentioned that the side of this triangle AB is AB, and the length of the side is AB dash. I was wrong. I'm sorry for this. I apologize for this. I was wrong. Actually, the side AB is actually denoted by AB with a bar. with a bar means it's a line segment, and the AB is actually the length of the side AB. So you can take it as length of AB bar. AB bar is actually the name of the side AB. V is equal to V denoted by AB. I was discussing the other way around. Anyway, I'm sorry for that. I just wanted to clarify this. So length of BC will be BC, and length of CA, the sides are AB, BC and CA, will be CA. So this is the actual convention regarding the name of the sides and its length. Okay, let it be. So so we have, if we name this triangle XYZ, we have the sides named by taking two letters at a time from the triangle name XYZ. First two letters is XY, so the first side is XY, and this side XY, its opposite angle is Z. That is the letter which is remaining apart from X and Y. Similarly, the next side will be YZ, and its opposite angle will be angle X, and the third side will be ZX, and its opposite side will be Y. So if I name this triangle XYZ, we have the sides XY, YZ, ZX, and angles, of course, they remains the same. They are named by the letters of the vertices, that is X, Y, Z, and the vertices are X, Y, Z. The main thing is the sides. The main thing is the sides, because the length of the sides will actually be used in determining the congruency of two triangles. So this is how when we name a triangle, when we give a name to a triangle with three letters, then what are the names of its sides? This you should understand very clearly. Now, if I, let's say I, so now, okay, now let's say I have a triangle XYZ. Just to give another example, and I name this triangle as ZXY. So if I name this triangle ZXY, then the sides will be, I will take the first two letters ZX, then the side will be XY, then the side will be YZ, and of course this will be opposite, this side will be opposite to angle whatever letter is remaining, that is Y, and this will be opposite to angle Z, and this side YZ will be opposite to angle X. So this I just wanted to give a brief recall regarding the naming convention of triangles, its sides and angles. Okay. Now these are all basic and foundational concepts that you need to understand very, very clearly before before studying the conditions of congruency of two triangles. Okay, the next one is, how do we express a matching or correspondence of sides and angles of two triangles? Now, so you can we are studying about congruency of two triangles, and you know that two triangles, even though I will be discussing the actual congruency of triangles in the next video, I'm just discussing it very briefly. We know that we have already discussed in the previous video part 1 that two figures are congruent only when their shape and size exactly match. That is, let's say in terms of triangles, I have a triangle ABC and a triangle let's say PQR. Let's say PQR. And so if I want to verify whether these two triangles are congruent or not, what I need to verify is that these two triangles have the same shape and size. Now, how do we verify that? How do we verify two plane figures have the same shape and size? We use the method of superposition. That is, we try to put one figure on top of the other, and if they perfectly overlap, if one figure perfectly covers the other one, then we say that these two figures or triangles are congruent. Now, when we will verify the congruency of two triangles, in this case, let's say AB and C and PQR, we will try to superpose this triangle PQR on top of ABC. Now, in doing that, definitely a particular vertex of triangle PQR will match with a particular vertex of triangle ABC. I mean, let's say, I don't know whether I will be able to show it properly or not. I'm trying. Let's say these two triangles as of now are looking having the same orientation, looking same and congruent. Now let's say I rotate this. Now if I have to check whether these two triangles are congruent or not. I have to see if I can overlap this triangle with the triangle ABC or not. No, I cannot overlap. Now so when I will try to overlap, when I will try to put the triangle PQR on top of triangle ABC, I have to be very specific that which vertex in triangle ABC I want to drop the vertex P, and which and on which vertex in triangle ABC I would like to put the vertex Q of triangle PQR. These I have to mention. So what exactly is happening is that I am trying to establish a correspondence between the vertices of these two triangles or the sides of these two triangles. So this is exactly what we will try to understand now under the title when we say expressing a matching or correspondence of sides and angles of two triangles. So when that is now what does it mean? What does it mean by a matching or correspondence of two triangles? So in this figure you can see there are two triangles ABC and PQR. ABC and PQR. Now when I say that, how am I going to match or create a matching or a correspondence of these two triangles? By that I mean I have to specify to which vertex in triangle PQR I will match the vertex A of triangle ABC. Similarly, to which vertex of triangle PQR I will match the vertex B of triangle ABC, and similarly to which vertex in triangle PQR I will match the vertex C. Now as soon as all the vertices are matched, automatically the sides will also be matched. So I hope you got the idea. Now how do we, so what we are actually doing is, when in expressing a matching between two triangles, we are stating, we are giving a mapping of the vertices of the two triangles or the sides of the two triangles. So now how do we mathematically express this? How do we mathematically express a matching of the sides and the vertices or the angles of two triangles? So this is done with the syntax. The first triangle, let's say it is ABC. The first triangle is ABC, and when I say ABC, and when I say that I'm creating a mapping, I'm creating a matching or correspondence between the triangle ABC and triangle PQR. This is mathematically expressed as this symbol. This is the matching or correspondence symbol. I write it like this. Now what does this mean? But I mean, when I write this, how do I know what kind of mapping is established between triangle ABC and PQR? Which vertex to which vertex A is mapped to which vertex B is mapped to which vertex C is mapped to, and all the sides, and what are the mappings of all the sides of ABC with the sides of PQR. Now in this mapping convention, it is very, very important that how do you name the triangle. This ordering of the letters, that is the vertices of the triangle ABC, ordering is very, very important. It will play a major role, and also the ordering of the letters of the vertices of the triangle PQR. If you alter this ordering, the whole meaning of mapping or correspondence will change. Now, if I have this, if I say this, the triangle ABC, I am naming the triangle ABC is mapped with or is having a correspondence or a matching with the triangle PQR, this will mean that I am mapping the vertex A of triangle ABC with the vertex P of triangle PQR. So I take the first letters. So I am mapping. So what are the mappings of the vertices? The mappings of the vertices will be like this. You take the first letter of the triangle ABC in the name, in however way you have named it. The first letter is A. You take the first letters of the first letters of the names of the triangle. Then you take the second letters of the names of the triangles, and then you take the third letter of the names of the triangle. So this is how we are getting the mappings of the vertices. That is, the vertex A of triangle A is mapped with the vertex P of triangle PQR. Sorry, vertex A of triangle ABC is mapped with the vertex P of triangle PQR. Vertex B of triangle ABC is mapped with the vertex Q of triangle PQR, and vertex C of triangle ABC is mapped with the vertex R of triangle PQR. Now also it will automatically imply that the sides are also mapped accordingly. Now what are the sides of the triangle ABC? As you can see, when we name a triangle like this, the sides, if the name of the triangle is ABC, the sides will be AB. So AB will be mapped with PQ, and BC will be mapped with QR, and CA will be mapped with RP. So this is how we get the mappings of the vertices and the sides of these two triangles when we express a mapping between the triangles ABC and PQR, and in where the naming of the two triangles is very important. That is the order of the letters of the two triangles. Also, also it is clear that angle A is mapped to angle P, angle B is mapped to angle Q, and angle C is mapped to angle R. Please understand one thing very carefully, that I am not yet talking anything about congruence. I am talking about a matching or a correspondence between two triangles, because these correspondence or matching will be used in verifying the congruency of two triangles. Congruency of two triangles is based on a particular matching or correspondence between two triangles. So that is why I am discussing what is a matching or a correspondence between two triangles. Now, okay. So in the notes you can see that where is this? Okay, so if we have these two triangles ABC and PQR, and if I'm expressing a mapping or correspondence between these two triangles as triangle ABC is mapped to triangle PQR, where the ordering of the letters ABC and the PQR is very important. Then if it is like triangle ABC is mapped to triangle PQR, we will get A mapped to P, vertex A mapped to vertex P, vertex B mapped to vertex Q, vertex C mapped to vertex R. This is mapping of vertices. Now mapping of sides, AB will be mapped to PQ, BC will be mapped to QR, and CA will be mapped to RP. And similarly, mapping of angles, angle A will be mapped to angle P, angle B will be mapped to angle Q, and angle C will be mapped to angle R. Now, you can obviously understand that is there only a single mapping or correspondence between two triangles? No, there are total 6 ways you can express mapping or correspondence between two triangles. For this, for a triangle ABC, for two triangles ABC and PQR, this is one way of expressing a mapping. Let's see another mapping. Let's say I have ABC. If I just alter the name, the letters of the other triangle, if I say P or Q, the whole mapping on the correspondence will change. Let's see. In this case, A will be mapped to P, which is same. B will be mapped to R. It has changed. And C will be mapped to Q. It has changed from the previous mapping. So also AB is mapped to PR, which has changed. BC will be mapped to RQ, which also BC is mapped to RQ is similar to the previous one, which is BC mapped to QR. RQ and QR is same, and CA is mapped to QP. So if you have for this, if you just so you can understand, if I just change the ordering of the letters in any triangle, then the whole mapping and correspondence gets changed. Now let's take another example. Let's say if I do, let's say CAB is mapped to triangle RPQ. If this is the mapping I specified, then the mappings of the vertices and the sides are C is mapped R, A is mapped to P, and B is mapped to Q. And the sides in the triangle CAB will be CA is mapped to RP, AB will be mapped to PQ, and BC will be mapped to QR. I hope you understand. Hope you understood that the ordering of the letters in the two triangles is very important when you express a mapping between the two triangles. Now, please you can try this out as an exercise, that there are 6 total ways you can specify a matching or correspondence between two triangles. If the two triangles are ABC and PQR, I have written down, these are the 6 possible ways you can mention a mapping or correspondence, a matching or correspondence between the two triangles. You can try this out. You can try it as an exercise. So if you take two triangles ABC ABC and another triangle PQR, you just try to map try to map differently the vertices of the triangle ABC to the vertices of triangle PQR. Then you can easily find out that these are the 6 possible ways of expressing different matching or correspondence between the two triangles ABC and PQR. Okay. Now finally, we discussed about how do we express a matching or correspondence between two triangles, and so when we express a matching or correspondence, based on a matching and a correspondence only we verify whether two triangles are congruent or not. Now in verifying whether two triangles are congruent or not, eventually we will have to see that so let's say we have these two triangles ABC and PQR, and we are trying to verify whether these two triangles are congruent or not. Okay. Now that is, we are trying to check, are these congruent? Now if you have two triangles, now these are plane figures. Triangles are plane figures. They have some vertices, 3 vertices and 3 sides. if you just ask uh, whether these two triangles are congruent or not, it will be an incomplete question. The question is not complete. It cannot be answered. You have to say you have to give the correspondence or the matching under which you are trying to verify that the two triangles are congruent or not. That is, the correct way of the correct question regarding the congruency of the two triangles ABC and PQR would be, R is triangle ABC, I can say like this, is congruent to PQR. I can ask this. If I say this, then I am automatically creating a mapping or correspondence between the triangles ABC, because if I say this, you know that this means this mathematical expression with this symbol in the middle with two parallel lines and a tilde sign on the above, this is the symbol of the congruency. So when I specify this, that is on the left hand side I have a triangle named, and on the right hand side I have a triangle named, I am automatically specifying a particular matching or correspondence between the two triangles, which is triangle ABC, this mapping. And we know what this mapping means. We know we have just studied or discussed about this. When I say that a triangle ABC is congruent to triangle PQR, I automatically mean to say that these two triangles are congruent under the matching or correspondence of triangle ABC is mapped to triangle PQR. Now, so we know that I am trying to map the vertex A with vertex P, vertex B with vertex R, vertex C with vertex A with P, B with Q, and C with R. Similarly, I am trying to verify the congruency of these two triangles under the mapping. I will try to map A with P, the vertex A with vertex P, vertex B with vertex Q, and vertex C with vertex R. Similarly, I will map the side AB with PQ, BC with QR, and CA with RP. Now, why those matching and why that matching is required to verify the congruency of two triangles? Because eventually, let's say I have two triangles. Let me give it a proper shape with the proper tools. Let's say I have two triangles ABC and PQR. When I will try to verify that whether these two triangles are congruent or not, eventually I will try to use the method of superposing. That is, I will try to place the triangle PQR on top of triangle ABC and see that if they are it is not congruent, it is not overlapping properly, because these two triangles the drawings are not perfect. So I will try to overlap these two triangles perfectly. Now when I will try to overlap, I will have to see, I will try to put the vertex P on top of the vertex A, not A, based on this mapping, based on I have this mapping. I am trying to verify this congruency. Now this I am trying to verify this congruency. This automatically means that I am trying to verify the congruency under the mapping of this, which automatically means that I have to place the vertex P of the triangle PQR on top of the vertex A of triangle ABC, and the vertex Q has to and I have to place the vertex Q of triangle PQR on top of the vertex V of triangle ABC. This is the mapping under which I have to verify the congruency. So I will try this. I will try to place the P, and I see that it is not congruent because the vertex R and C are not mapping properly. Anyway, so I just wanted to visually show this. So now the last point is that 3 sides and 3 angles are the 6 matching parts of congruence of triangles. Congruency of triangles. Now, if I am trying to verify whether 2 triangles ABC is congruent to triangle PQR, I mean 2 triangles ABC and PQR are congruent or not, eventually I have to see. I mean, in doing mathematics, in solving problems, definitely you will not use the method of superposing. You have to see whether all the 3 sides of one triangle, if the corresponding sides of one triangle is having the equal length with the corresponding sides of the other triangle, and also the corresponding angles. The pairs of corresponding angles of the 2 triangles are equal or not. So what this point, the 3 sides and 3 angles are the 6 matching parts of congruency of triangles, is means that when we will solve problems, we will eventually have to see whether the 3 angles of one triangle is equal to the 3 angles of the other triangle, and also the 3 sides of one triangle is equal to the corresponding the lengths of the corresponding sides of the other triangle. So this is what it is saying, that we in determining the congruency of 2 triangles, we need to match 6 things, that is 3 sides and 3 angles. So in triangle ABC, the 6 matching parts are the sides AB, BC and CA, if I name the triangle as ABC, and the angles are angle A, angle B and angle C, and the 6 matching parts of the triangle PQR are the sides, 3 sides PQ, QR and RP, and the 3 angles P, Q and R. So eventually I will have to eventually see which side I have to check the length of the side AB, whether I have to check which side I have to check that the length of the side AB is equal to the length of the side PQ. So if I'm trying to verify triangle ABC is congruent to triangle PQR or not, I will see, since I am trying to verify this congruency, I know the mapping is ABC. Triangle ABC is mapped to triangle PQR. So I know that I have to see whether AB is equal to PQ or not. I have to see whether the side BC is equal to the QR or not, and the side CA is equal to RP or not. So I have to, I have to check this, I have to check this, I have to check this, and also I have to check whether angle A is equal to angle P or not, angle B is equal to angle Q or not, and angle C is equal to angle R or not. So for checking this, so we have to check this. So this is precisely, it is saying that, so these are the, so the sides, the 3 sides and the 3 angles of a triangle are the matching parts which will be eventually used to match with the corresponding sides and angles of the triangle, whether it is equal or not, to verify the congruency. So this is all about matching and correspondence between 2 triangles, which will be used, which will be heavily used in determining, in verifying the congruency of 2 triangles. Because when we say ask whether two triangles are congruent or not, we have to mention the matching, under what matching, or under what correspondence we are verifying the two triangles to be congruent or not. And in the next video, part 3, I will start discussing the 4 conditions, that is the 4 conditions which will 4 different conditions which using which we can say whether two triangles are congruent or not. And they are the 4 conditions are the side condition of congruency. We have side angle side, that is side angle side, condition of congruency, angle side angle, and RHS. So in this, I'm just briefly discussing these 4 conditions of the congruency of two triangles. I will definitely elaborately discuss this in the next video. So SSS is basically, we are trying to based on, we will try to see whether 3 sides of one triangle is of equal length to the 3 sides of the other triangle. And in SAS, A stands for side A stands for angle, and R stands for right angle triangle, and H stands for hypotenuse. In SAS, what does SAS condition is? SAS condition is that we try to see whether 2 sides of a triangle and one angle. SAS means 2 sides and the included angle. So if you have 2 sides in a triangle, let's say I have a triangle ABC, SAS means if SAS 2 sides, I am matching 2 sides. Let's say I have the triangle PQR. Let's say I am trying to match whether the AB is equal to PQ and BC is equal to QR, and also the included angle between the sides, that is angle B for triangle ABC and angle Q for triangle PQR. So this means 2 sides and the included angle. So if I am trying to verify, if I am trying to check whether the sides AB and BC is equal to the sides PQ and QR, then the angle that I will check is the angle between the sides AB and BC, which is angle B, and the angle between PQ and QR, which is Q. So that is SAS. And what is ASA? ASA is angle side angle, that is one side and its adjacent angles. You know that what does it mean if you have a triangle ABC? If you you take any side, let's say I am taking side BC, the angles adjacent to the side BC are B and C. Similarly, the angles adjacent to side AB is A and B. So if I'm checking whether if I'm considering the side BC, let's say I'm considering the side BC and the side PR in the SA congruency condition of congruency, I will check one side and its adjacent angles. So if the one side for triangle ABC is side BC, and if that one side and if I am trying to check whether BC if I see that BC is equal to PR of the triangle PQR, then I will also have to check the angle B is equal to I will also have to check that angle B is equal to angle R and angle C is equal to angle P. That is, the adjacent angles of the side BC should be equal to the adjacent angles of the side PR. And what is RHS? RHS is determining congruency of 2 right angle triangles. So if you have 2 right angle triangles, let's say ABC, and we have another right angle triangle, let's say PQR. If we know that one angle is definitely common, that is 90 degree, and if you have the hypotenuse same, if this AC is equal to PR in 2 right angle triangles, if the hypotenuse are same, then you need to check if any arm is equal to the corresponding arm, if the corresponding arms, any one of the corresponding arms of the two triangles are equal or not. So if the congruency that we are trying to verify is this triangle PQR, then we know that definitely in triangle ABC, if CA is the hypotenuse, then RP will be the hypotenuse in triangle PQR. And so now we will check whether AB is equal to PQ or BC is equal to QR or not. If one of them is equal, if one such pair is equal, that is, by pair I mean AB and PQ, or another pair is BC and RQ. If any of these pairs are equal, that is, if any one arm, if any corresponding arm of the two triangles are same, then we can say that these two triangles are congruent. So this was just in very brief about the SSS, SAS, ASA and RHS. I will discuss them in more details in the next video. So this video was to give you a foundation about the matching and correspondence between two triangles, which will be which you should understand very clearly to understand the congruency of two triangles. So if this video was beneficial, then please like it, share it with your friends, and also please do not forget to press the bell icon so that you will be notified by my future videos. And once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Please stay tuned for the next video, where I will discuss about the 4 conditions of congruency of two triangles, that is SSS, SAS, ASA and RHS. So until the next video, take care and bye.